We'll, we'll proceed in pseudo multivariate calculus. Pseudo multivariate calculus. This is amazing. This is mind blowing in a sense that we are trying to find out a way to write a story. Someone, when he sees a mathematical problem, then he starts sweating how to tackle it. Should I use calculus? Then where I have to use dx, dy, dz, dy by dx, dp by dx. There is something called position vector by dx also. dp by dx, okay, dp by dx or dy by dx, dy by dp by dxy plane, and people they try to leave the calculus. It is very cumbersome. It is something that is difficult to tackle. Okay, so just leave it. Okay, better to study something that is not related to calculus, statistics, or here and there. Things are easy. Anyway, we are trying to find out a way where a simple mathematics would slowly it would turn into calculus. People have to write the algorithm with simple multiplication and division, and it will turn into calculus. Okay, that is the idea, because we know that integration is nothing but simple multiplication only, where if I have a into b and a is dependent upon b, then it is a d of b. Okay, it turns into integral calculus. If I have a by b and a is dependent upon b, a is a function of b, then it is dA by dB. That's it. Then after that, people know what is the differentiation formula and integration formula. Simple, right? Anyway, now in that we are in series of doing the calculation. If the independent variable is 1, then we use length vector. If independent variable is 2, then we use area vector. If independent variable is 3, then we use volume vector. If independent variable are 4, then we can use weight vector, and so on. So how many independent variable are there? We do like that. We were in, okay, we will go ahead. We were talking about the force into displacement. Force into displacement gives the net energy calculation. Force into displacement gives the net energy calculation. Where displacement can be mentioned through a length vector. So force dot product with the length vector, where length vector is altogether, it is full medicine with vector, algebra, calculus. What is length vector? We have taught. Length vector in Cartesian coordinate system is I plus dy by dxj bracket close into dx. Actually it was xi plus yj. It turned into x and then I plus y by xj. Then it turned into I plus y by xj bracket close into x. Y by x, y is dependent upon x, dy by dx. Whole this vector is dependent upon x, that is outside. Then 1 plus I plus dy by dxj into dx. This is called length vector. This can be multiplied anywhere where length is required. And we were in phase of calculating the energy where force vector dot product with the length vector gives the net energy. In that sense, we were challenging that length vector for all the different paths. If I'm trying to length vector for a straight line, then dy by dx will be different. Mind it, whenever we talk about the length vector, it is I plus dy by dxj into x dx. How it came is, it came from a story. It came from a story where we were trying to calculate the length of a straight line. This is x-axis, this is a straight line. This is origin and this point is x comma y. What is length of this line section from origin to x comma y? It is same as if I represent it through vector xi plus yj, calculating the magnitude of xi plus yj, whatever. What is the vector? X 0 to x comma y, vector is xi plus yj. But if I try to find the length of a not only straight line, any curve line also. So this is a curve line. If I'm trying to find length of curve line, then from origin to any point x comma y, then again I have to represent this as a vector. But this curve line, this is x-axis, everywhere y by x is different. So whatever the vector we represented through xi plus yj, we have to make sure that y by x will come into the picture. Because if it is a straight line, if it is a straight line, then y by x, everywhere it is a number and it is same. Everywhere it is same. But if it is a curve, then y by x, every moment it will be different. So in that sense, y by x itself is variable. So if I need to find the curve length, then it will xi plus yj, the magnitude of xi plus yj, rather we say it is I plus y by xj into x. Now y by x comes into the picture and it is variable and y is dependent upon x. So I plus dy by dxj into dx. This is called length vector. If I calculate the magnitude of this, certainly it will give the length of the vector. Someone can try. Well, where is the difference between all the different shapes is dy by dx is different, and then multi dx, that integration is different. Altogether it is different with different kind of curve. Anyway, if I multiply this length vector with force, it becomes energy. Okay, that is the science. If I multiply this length vector with if I divide this length vector with the speed, it becomes time. If I divide this length vector with time, it becomes speed. That we will see. Amazing, mind blowing. Okay, I am going to patent this length vector. This science is not available in any of the book. Someone can see it. Length vector, area vector, volume vector, weight vector. In that sense, in kind of space sciences where there are many planets, they rotate around their star, or many satellites, they rotate around their planet in a non-circular fashion, in an elliptical space, in elliptical orbital path. In that sense, the speed of that satellite or planet in its orbit is speed is dependent upon at what distance it is from the center. If Earth is rotating around Sun in a circular path, then at everywhere the path distance from the Sun is same. Whereas Mars rotate around Sun in elliptical path. Sometimes it is very far, sometimes it is near. And the speed at which Mars rotates around Sun, the speed at any moment is depending upon how far it is from the Sun. If it is very far from the Sun, then the speed at which Mars will rotate will be less. When it comes near to the Sun, then the speed at which it will pass through the Sun, that speed will be high. Means at different, if it is elliptical shape, at different angle or at different position, the speed is different. In that case, can someone calculate what if I give the distance, then what will be speed at any moment? That someone can calculate. Okay, the idea is, can someone calculate the average speed of the planet or average speed of the satellite in non-circular fashion? Okay, these are the way where length vector will be used heavily. Anyway, I'm going to give one example. We will take in last session video, we had a kind of can we prove that our length vector is indeed it follow the science of path independence. Length vector dot product with the force vector gives the energy involved, and this should be same between 2 points if force vector is path independent. Like Earth gravitational force is path independent. If any item is falling from this point to this point in a straight line, make a straight line connect the origin to any point x comma y. Okay, if someone connects x comma y with this point, straight line. Okay, if something goes x comma y to origin in a straight line, then the energy involved. If anything goes toward Earth, Earth loses energy. After all, someone is working, right? There is nothing called gravitational force. These are bad, wrong words. gravitational pull and this kind of thing. Okay, actually there is something called energy involved. If there are two masses, the bigger mass would attract the smaller mass. Okay, attraction is all right, but if understandable, right? I don't know where that is gone. Okay, I have a bigger mass. Okay, I really have a bigger mass and I have a smaller mass. Now consider, this is the earth, this is earth, and this is moon, and moon is getting attracted toward earth. That's why moon is rotating. If it does not rotate, then it will collapse on the earth. So that's why in the space science, Halia mission in Arabic, Halia. So in space science, every item is rotating around the bigger item so that it will not get attracted. Okay, now there is a philosophical question: is universe is rotating around whom? That is a big question at the end. In universe, everything is rotating around the bigger thing. Sun rotates around the Sagittarius, that is the black hole at the center of Milky Way, and full Milky Way rotates in a local group at the center of the local group. That is very massive black hole around which Andromeda and Milky Way also rotate. That is called local group. I don't know if local group, so many local groups, they would be rotating around something else. At the end, universe rotates around whom? Because if anyone does not rotate, then he will try to fall somewhere. Okay, there are many philosophy in people's life also. If people does not work, people does not rotate, then where it will fall? But certainly it will fall. So to avoid the falling, someone has to rotate anyway. Now consider that moon is not rotating around the earth, and then moon will start attracted toward the earth. Now leave the concept of moon. This is earth and this is a simple item. This item is going toward the earth. If there is a motion that is happening, then certainly energy is involved. Someone is losing energy. That's why this item getting energy and it is moving toward the earth. If I just leave it, if I just leave it, then it went toward the earth. Earth lost energy. Earth, who paid for it? If it is getting motion, speed, and then moving, after all, it needs energy to move. Who paid for it? Earth paid for it. Earth lost the energy. Now we will see the discussion that force dot product with the length vector. The idea we have come up now: length vector, area vector, volume vector, weight vector. Force vector dot product with the length vector, it gives the how much is the energy that entity is losing. If this is falling like this, then how much earth is losing energy when length vector is towards the pole. So if consider length vector, if I say this point is x comma y, okay, and this point is origin. Just consider like this. This point is x comma y. This point is origin. This is x axis. This is y axis. In that sense, how much energy Earth lost moving item x comma y to origin? This doesn't look like a straight line. Okay, if it is a tilted line, if it is a tilted line, then this is a line that connects x comma y and origin. If it falls like this, along this, then how much energy Earth is losing? And if it falls like this in a curve fashion from this point to this point, then how much Earth is losing? Earth gravitational force is path independent. It does not matter what path someone is choosing. If it is going from x comma y to another point origin, or x2 y2 to x1 y1, then what path it takes, it does not matter. The force or energy that will be lost by the earth, it matters the beginning point and end point only, not on the path. But we are calculating the energy of the earth is gravitational force of the earth dot product with the length vector. And length vector is I plus dy by dx j whole multiplied with the dx. Dy by dx is different for different length. Then it will come to different energy. but it should be the same when limit, lower limit and higher limit of the path is same. That we will talk little later. If time permits, then we will talk. But this is how it is. Let's do more exercises so that it would be more clear. Okay, I have a simple question. I have a simple question. The question is, okay, we'll come to bigger question. Bigger question is, consider this is sun, this is sun, and this is Mars. Up, 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 up. This is sun, okay, and this on this axis, Mars is rotating. So Mars is rotating around sun. Mars is rotating around the sun. Okay. Now at any moment, distance is r. It is moves in elliptical shape. Okay, when distance is r, at that moment, the velocity of the Mars is gm. Gm. G is gravitational constant. M is mass of the sun. Gm divided by Gm divided by r square root. R is the distance between Mars center and sun center. Make sense? So sun center and Mars center distance is r. If sun is here at the middle, center of sun is here. When Mars is rotating, center of the Mars is center of this ball. Now at any moment, this is elliptical shape. Elliptical shape in the sense that hope I'm going to really make it elliptical. Okay, this is elliptical shape. Now, when Mars is here, distance is big. When Mars is here, the distance is small. Here, the speed of the Mars will be higher. Here, the speed of Mars will be less. Velocity at which Mars travels around Sun is inversely proportional to the square root of radius. This is what we saw. Please watch a previous video on mystery of universe. So mystery of universe in the sense why moon, okay, that we have to find out. Why moon rotates on its axis only once in a full rotation of the earth. Moon takes 27.2 days, I believe, to make one rotation of the earth. In one rotation, moon also rotates one time along its axis. Why? Whereas Mars rotates around the sun, but in 24.24 hour 37 minute or something like that, it rotates on its axis. Okay, like that, I believe Mercury more or less it rotates on its axis, same as it makes a one movement, orbital round rotation of the sun. Why? Okay, more or less, I believe 80 days it takes to travel around the sun, whereas 57 days or something it takes to rotate around itself. Why? Why Earth takes 24 days, whereas rotation is 365 days? Why? Okay, there is nothing away from the science. There is nothing away from the science. Everything is crystal clear, fixed by picometer in the distance and by picosecond in the time. There is nothing that is, let's consider that. There is nothing like that. Okay, in that fashion, when it is at distance r1, then the speed of the mv square equal to gmm by r square by r. That was the formula that we saw in the mystery of universe. Then v square equal to gm by r, v equal to gm by the square root of r. G is constant, m is constant. In that sense, the velocity of Mars is inversely proportional to 1 by a square root of the distance from the center of the sun. If distance is more, less velocity Mars will catch. As distance is nearing to the sun, more velocity it will catch. Here, the velocity will be maximum. Then velocity will start decreasing, and velocity will be minimum, then maximum, then minimum, and then slowly it will grow, slowly it will decrease. Now, can someone find the average speed of the Mars? That is the question. Now, let's try simple thing. Now, this is hop. Okay, someone can try. I'm not stopping anyone. Someone can try. Okay, this is a road. This is a road. And on this hop, one. Okay, no problem. Okay, this is a road and this is origin and a person is running on this road. Okay, now what is the speed of the person? Speed of the person is 1 by a square root of distance r. Consider this is the r. 1 by a square root of the r. If person is from here, person is at 200 meter, then his speed is, I'm sorry, I believe I'll make it square root of r. So when person is at distance of 200 meter, his speed is square root of 200, square root of 200, whatever comes meter per hour. That is his speed. If person is at 1 kilometer, the speed is square root of 1000 meter, 1000 meter per hour. If person is at 10 kilometer, then his speed is 10 into 10,000. That will come, a square root of 10,000 will come as 100 meter per hour. That is his speed. Someone can say per second, whatever comes to someone's mind. Anyway, if that is the scenario, then can someone calculate the average speed of the person, average speed of the person at any distance r? Make sense? At any distance r from the origin, if this is the origin and person is running at a speed of a square root of r is the distance. More distance is covered, speed is growing. Okay, so something like that. At any distance r from the origin, what is the average speed at which he is running? Average speed means if from zero, if he is traveling from origin to any distance r, what is the time he took? Consider he took the time t. Then t into average speed will give the distance. That distance is same as consider he took the time to run a distance of r in time t. Okay, then if t is multiplied with the average speed, the same distance will come. Consider he is covering a distance of r and he takes time t to cover this distance. If his average speed is s, then s into t equal to r. Otherwise, whatever the speed right now is the square root of r, this into time will not give the net distance. Certainly not. Now that is the question. Can someone solve it? A person has started from the origin. A person has started from the origin and he is running. Okay, his speed is square root of r. The distance he is covering, that distance he is, okay, if someone has problem, then I can convert it to x. He is running on x axis. Then a square root of x is the speed. If he is at 100 meter distance from here, then his speed is 10 meter per hour. 10 meter per hour. If it is has 10,000 meter away, then his speed is 100 meter per hour. Speed is growing by square root of the distance. What is his average speed till any distance r? If he ran to distance any distance r or any distance, consider any distance x, any distance x, then what is his average speed? Can someone calculate it? Okay, now now how we go with our length vector? Now we'll calculate the total time that person is taking to travel distance x. Now the distance by total time covered is the average, is the distance by distance by speed will give the time, that much time he has covered. Now someone will say, how I can say it is, tell me how much time it will take. Then I will say at distance x, distance you are saying x, right? And then his speed is square root of x. At any moment x, his speed is square root of x. Or I say distance alpha. Okay, let's keep it x only. Well, how much time it takes? Time is equal to distance by speed. Distance is x and speed is square root of x. That is the time. Certainly not. At the beginning, his speed is less. More he is going, speed is growing. There is acceleration actually. In that sense, the distance by time will not, distance by speed will not give the net time, not possible. But let's go with that. That's why we have come to a topic called pseudo, pseudo multivariable calculus. Write a pseudo code. Okay, pseudo code is total time equal to distance by speed. What is your distance? Distance is x. Distance is x. Okay, or distance is considered, distance is d. Distance is d, and the speed is square root of x. At any moment, if he is traveling x distance, then it is square root of x. The total time is total distance by square root of x. Make sense? Okay. Now the distance can be replaced with the length vector. So pseudo calculus is proceed with the normal mathematics. Distance by speed is the total time. Whatever is the distance by total time. Total time is square root of x, where x is variable. Okay, depend upon the at what distance he is, that is the speed, square root of x. What about the distance? Distance is the length vector. Length vector by square root of x will give the net net time, and that length vector is I plus dy by dxj. I plus dy by dxj into dx. And now, what is dy by dx? The person is running along x-axis. There is no y. There is no y. Means y is 0. Dy by dx is 0. There is no change in the y if person is running along x-axis. Makes sense? So, blindly, someone can keep dy by dx is 0. It becomes I dx. Now there is no vector manipulation here. We can take the magnitude of I dx, that is dx. Now it comes as dx by square root of x, that is the time. Now square root of x, dx by square root of x. Now how much it will come? Dx